What if tonight the moon quietly collapsed into a black hole and nothing much changed? No tidal apocalypse, no orbital chaos, just a darker sky, a colder Earth by a hair, and a sand-grain doorway to forever hovering where our moon used to glow. Wild, right? Let's open that door. Here's the thought experiment. Replace the moon with a black hole of the same mass and in the same orbit, same gravitational pull, same position in the sky. Different everything else. Because a lunar mass black hole, its event horizon would be tiny, about the size of a grain of fine sand. You could pour it through a number 70 sieve. Well, it would pour through anything on its way to annihilating it, but you get the point. Cosmically massive, physically microscopic. And that scale is where the surprises begin. First big twist. Earth's motion and our tides barely notice. Outside a spherical mass, gravity only cares about total mass, not whether that mass is a dusty grey globe or compressed into a pinpoint. Same mass, same tug. If you swapped the sun for a same mass black hole, Earth's orbit wouldn't budge either. Daylight would, survival would, but the ellipse stays. So no rogue tides, no orbital doom, just no moonlight. With the moon gathered into a point, its glow disappears. That seems trivial until you remember that moonlight actually nudges Earth's temperature. Observations show a 28-day temperature wiggle. All else equal, Earth is warmest around the full moon. The biggest driver isn't visible moonlight, though. It's geometry. Earth sits slightly closer to the sun at full moon than at new moon, and that still happens with a black hole moon. But the moon itself also warms up under sunlight and re-radiates heat in infrared. That infrared moonlight subtly warms our planet, about 1.2 millidegrees Fahrenheit. Yes, milli. The bottom line, remove moonlight and Earth cools a smidge. Given our current rate of CO2 warming, we'd erase that dip in a couple of weeks. Not exactly an ice age. Would our new moon glow from Hawking radiation? Not this one. A lunar mass black hole actually absorbs more energy from the cosmic microwave background than it emits via Hawking radiation, so it stays truly black unless it eats. If it accretes something, the infalling material can blaze brilliantly in an accretion disk. But out there, not much to munch. Mostly it would quietly herd nearby dust, one sand grain bossing other sand grains around. No moonlight means big changes for nocturnal life that cue behaviours to lunar phases, spawning, migration, hunting, nesting. It's a shift, but compared to the disruptions we already impose on ecosystems, light pollution, habitat loss, this ranks as not catastrophic, just consequential. That full moon warmth bump? Remember, the dominant contributor is Earth's slightly altered position relative to the sun across the lunar cycle. That geometry persists, so the 28-day temperature wiggle persists, just a touch smaller without the moon's infrared re-radiation. A climate footnote, not a headline. Day to day, our black hole moon would be low profile. It wouldn't lens the sky in some dramatic way you'd spot with the naked eye. Its horizon is too small. Most of its work would be subtle, tidying dust or exhaling the faintest whisper of radiation if it ever snagged a pebble. In other words, a celestial minimalist. But if you replace the moon with a black hole of the same size as the moon, not the same mass, then all bets are off. A moon-sized black hole would pack something like 600 suns worth of mass. Earth doesn't survive that story. We fall in. Total, final, forever lunar eclipse. So the paradox lands here. A black hole moon sounds apocalyptic. In practice, with equal mass, it's mundane. Our tides stay tame. Our orbit stays steady. The night goes dark. Earth cools by a whisker. No dramatic Hawking glow. A sand grain horizon where a disk once shone. The cosmos keeps spinning.